I am Dean Bushmiller with Expanding Security, and this is Information Technology Security Principles and Practices. Use or consumption of this material by AI is expressly forbidden. Let's get started. When I went to go look for information technology security, the words themselves, I really struggled with this in everything that I was doing. And quite frankly, the reason why is because there's some problems with the definitions. If you look in the definitions, really what you want to know is ITSEC different from cybersecurity? And the short answer is, well, usually when we talk about ITSEC, we're talking about internal versus cybersecurity where we're talking about external. And so we look at them differently. But the reality is it's an older term, it's washed away, and it's been folded up inside of cybersecurity as we understand it today. To give you a little bit of history on this, and we do need to talk about the history lesson because some of you may be going to NIST and saying, well, I want to get the definitions from NIST. They don't have a definition for information technology, and they don't have a definition for information technology security. They do have definitions for information assurance, which is an older term that I'm used to because gray hair, that kind of thing. They have definitions for information security and for cybersecurity. It's still not that definition. There are two other sources that I go to always look for things, and one of them is called Natick, which is a huge dictionary. It's about a 500-page dictionary on information security, and they have a definition for information technology, which when I was growing up, was known as IT, but just information technology. And that's hardware, software used for in connection with information, management and use of technology stored, processed, and shared. Okay, so there's this other resource, which I put in the links, which is AJP, and they have a definition for information technology security, ITSEC, which is what I've known all along. We never really called it that. The definition is, state of security in an information technology system. Okay, so I had to come up with what we're going to consider as ITSEC, information technology security, so that we could talk about the principles and practices in a cohesive manner. So we'll start with their definition, state of security within an IT system. And then I took all the other definitions and I brought them together. What are our core objectives? Well, we want to preserve the system's availability, integrity, and confidentiality. Those are the resources that we like. We want to protect against the opposite of those things, unauthorized access, data manipulation, data modification, data destruction, and denial of service to authorized users. So those are the inverses of each other, and okay, that's fine. Around the scope of these things, what is the scope? Well, I say it's the hardware functions, the software functions, system features, and characteristics. And so that's where we're going to limit our scope. But we also have to talk about, if it's security, we have to talk about controls, and the controls center around operational and accountability procedures. Those are like log management, those kinds of things. Access controls, physical structure, areas, and devices. And that's where we kind of shift a little bit. We're talking about kind of like guns and guards and dogs here, which we don't normally talk about in cybersecurity. And a lot of security certifications, like even the CISSP as of 2026, still talk about physical security. And you do too, you just don't recognize it because it becomes a part of your life. It's the badge that you carry around that allows you to get through doors. They also talk about management constraints, what we can do and what we cannot do based upon management saying this is the way the mission is going to run because of things like litigation, laws, requirements. Maybe it's an auditing facility that comes in. We'll also talk about personnel security and communications controls very briefly. Generally, in all of this, for ITSEC, we're going to say, whatever it is, we're going to ensure that the acceptable level of risk is addressed. That's our goal in all of this. If we implement ITSEC principles, because we are talking about principles and practices here, what would those be? Well, establish the objectives, the security objectives. Show management support. Management spends money on the controls. Manage risk, that means that they're involved in it. We have a risk management program. We put the controls in place. We monitor those controls. Implement architecture principles for sound judgment, so we don't just say, oh, I want to buy that because it's cool. Manage security incidents, so we have an incident response team, and integrate all of this into the life cycle. Those are the principles and practices together. This is interconnected with ITSEC and cybersecurity. They are mashed together. We're going to separate them out for this communication here, for this particular video here. But remember, these are all shoved together. And you can even go watch another video that I have that is cybersecurity principles and practices. And so you can compare the two and see how they differ. But after this presentation, we can go ahead and lump them in as the same, because we want to have all good quality practices that go along with our, information technology. Where is information technology? Where is ITSEC in AI? Well, the impact of artificial intelligence on information technology security is monstrous at this point. Let's talk about the offensive impacts for just a moment in time. The attack cycles have been radically reduced because of AI. To start off with, we have an average breakout time of 29 minutes as of 2026. And a breakout time is the interval between the initial access and the lateral movement. That means that an evil attacker gets into your network and sits on a computer. They find another resource inside of there, and it's called pivoting, and they go to that other resource and they capture that other resource. From here to there is 29 minutes. Boy, that's really fast. Automated reconnaissance using LLMs is a normal occurrence today. All of that reconnaissance information we can go ahead and program into LLMs. I've used a couple of them at this point. They're pretty good. Data exfiltration occurs within minutes of the initial access. So they set up those communication channels outbound. They start transferring data, even if it's just the basic logs that are sitting here locally. The social engineering has radically changed. So real-time deepfakes for executives impersonations, where your boss calls you up on a video conference and says, I need you to go ahead and turn down that firewall. And it's not really them, happening all the time. There are hyper-personalized phishing attacks that are going on out there. They take that reconnaissance information, they collect it all up, and they go, okay, we're going to throw it at you. But you think, okay, well, it's all about just me and they've tried to figure this out about me. No, what they did is they went and scoured LinkedIn and found every single person in the company and sent every single person a hyper-personalized phishing attack at the same time. Why? Because if everybody comes in and reacts to this and says it's bad, but one person at the very beginning says, I think I'll go ahead and take a look at this, and they click on that link, well, everybody else has reported it, and it's like, no, stop, and it's too late. Then you've got that 29 minutes that you've got to deal with at that point. The commercialization of AI-assisted cybercrime is huge today. That makes it easier for the cyber criminals, because when they set up the AI on that side, they don't have to do a lot of the extra work. There are new attack surfaces and new vectors of attack, and that's because AI is an asset inside of our organization. It is an IT asset, so we have to protect it as such. The defensive impacts and operational improvements include things like automated threat detection and response. So AI can handle a lot of tier 1 SOC alerts. AI can understand behavioral anomaly detection more readily than most of the previous systems that were out there. And it'll allow us to do autonomous containment. So we have agentic AI that can see that host, we're going to go ahead and, I got to block the firewall, and I got to set up the honeypot, and I got to turn off that user, I got to reset that. No, you don't have to do it anymore. The agent will go out and do that for you. I don't know if I would trust this with all of my systems, but I would at least, for account lockout for that one user, I think that would be a reasonable thing if I could issue an agent to do all of those activities for me. Vulnerability management and proactive defense has changed. We can do predictive analytics, identifying weaponized flaws before the public disclosure. So normally what we would do is we would go to the National Vulnerability Database and they'd say CVE ID, blah, 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 blah. And the vendor would go, okay, and here's the fix for that. Well, The attackers are attacking before this is announced out there, so they can actually get into these devices because they're starting to predict that attack before the patch is available. So it's kind of like a zero-day flaw. AI-assisted patch management is a reasonable thing to do today. Now, there are some transformations of security roles within our organization. The SOC analyst has changed. Your job is to supervise AI workflows. That means that your training is going to change into focusing on judgment and strategic reasoning rather than chasing after a little line item by line item. I hope you'll enjoy this entire presentation, and I hope you join me for the rest of it.